Yeah, thank you, Alton.
Thank you. So before we start, I'll just give you a small introduction of IBC, and then after that, we'll then hand over to Byron to start with the training. And I believe we'll be learning a lot from Byron today. So I'll just give you a small introduction about IBC Solar. So as IBC Solar, we offer different brands. We offer from modules, mounting, inverters, and storage systems. So on the modules and mounting side, we offer IBC solar modules. We offer logging modules, Jollywood modules, and also Canadian. Then on the inverter side, we have SunGrow, Attest, Goodweave, Victron, SMA, and the one and only for our focus today is Fronius. And on the storage side, we do have our own local battery manufacturer, SolarMD, and we do offer BYD and SunGrow battery storage solutions. So in the team, we have Daniel and Helga, who are in the managing position. So Daniel is the managing director, Helga is the head of finance and operations. And on the marketing team, we do have the one and only Zane, who's responsible for the organizing this training today. And on the CNI project space, we have Arno Dendal, who's the head of projects. Supply chain and sales administration. You'll see there we have Shemaine, Kim, Michaela, and Tanya. And on the accounting side, we have Hamu. Now, on the sales manager side, we have Leo and Jason, who are based in Joburg side. And in Cape Town, we have Kyle and Ridar. On the technical side, you have myself, Alton Bedzi, and Juante and Jama, who are situated in Cape Town, and we have vessels situated in Joburg. So if you do need technical support based on your region, you can contact either myself or vessel. So now something that we do have, just to let you know, we do record our webinars and they are available on our online shop. So if you do want to revert back to the trainings just to revise or just remind yourself of some technical issues, you can just go to our webinar recordings and you will find everything there. Now, this month we do have an IBC solar sales deal as we do every month. But this sales deal now that we have for this month is you get an extra 3% discount on the inverters if you purchase modules and selected inverters. So if you want to find out more about this extra 3% discount, you can then contact your sales manager and we will then, your sales manager will then guide you in order that you receive your 3 discount and let you know about all the terms and conditions there. Now, without further ado, on my side, I am done. So I'll give this opportunity to Byron to then start with the training. And yeah, Byron, we are looking forward to learning a lot from you.
Perfect. Thanks, Alton.
Thank
So for today, we'll be covering the Fronius product training. So this product training will cover both the Fronius Gen 24 Plus and standard version, as well as the step inverter range, and lastly, the Fronius Taro inverters. So who am I? So I'm Byron Kutzer. I am the technical sales advisor for the Southern African region for Fronius International itself. So again, as mentioned for today's agenda, we'll be covering the installation of Fronius Gen 24 Plus and snap inverters, as well as the installation of Fronius Taros, data communication. So this will be both covering the pilot card and data manager card, your initial commissioning of your Fronius Gen 24 Plus and Taro. So this will be more in depth on the pilot devices, the initial commissioning of the Fronius snap inverters. So again, this is more on data manager side and reservoir commissioning. Fronius smart meters, which are essential for all grid tie systems that are using Fronius inverters. Your visualization in Fronius Solar Web, the service and technical support, and then lastly, the system expansion and commercial PV systems. So to start off with, we'll do a quick overview of our inverter range. So as mentioned, we have got our snap inverter range. So we have got the Primo side and small and Simo small. So these are referring to units that are 3 kilowatt to 8.2. So both single phase or 3-phase. You've got 2 MPPT inputs and your input voltage range is from 150 to 1000 volts, which is at 16 amps. Then on the Fronius Simo Big or Advanced, so Simo Advanced. So these are 3-phase units, 2 MPPT inputs and power class 10 to 20 kilowatts. And again, your input range is 25 amp or 16.5 amp, depending on which MPPT you're going to be using. And again, the input range is 200 to 1000 volt DC. So the main difference between the Fronius Simo normal and advanced is the arc guard fault detection, or AFCI for short. So this is a algorithm that's written into the software on the unit, where it helps to detect the arcs on your DC side. So it takes a measurement before and after and during the day to make sure that there is no discrepancies between those measurements. And if there is, the unit will then go into an idle state to then in order to protect your PV system. Lastly, on the snap inverter range is the Fronius Eco unit. So this is again a three-phase. You got a single MPPT input on the unit, and then power class 25 or 27. But most commonly is the 27 kilowatt is available in the country. And this has an input range of 27 amps and then 580 to 1000 volt DC. So the input range is 580 to 1000, but what to keep in mind is on these units is the usable range. So for example, on the Simos, it's from 350 upwards, 400 volt DC upwards. Whereas on the Echoes, it's 650 volts and above is the usable range. So we typically advise clients to keep within 650 and 1000 of the unit in order to make sure that you are in the usable range of the unit. So on the Gen 24 series, so the Gen 24 comes in two different variations. So we have what we call the normal Gen 24 and Gen 24 Plus. So the Plus is referring to a hybrid inverter that you purchase out the box, whereas the normal Gen 24 is referring to a normal grid tie unit that can be changed into a hybrid inverter later on when the client is needing to do so. So again, it's available single phase hybrid inverter. You got 2 MPPT DC inputs on the PV side, as well as one battery input also located on your DC connection points for your battery inputs. Again, power class 3 to 6, but we have expanded this to 10 kilowatts coming into the country on the single phase side. And again, your input range, so we've split it between the two MPPTs. So you got 22 amps on the one and 12 amps on the other MPPT. And this is a voltage range of 65 to 600. And the way we get away with the lower voltages on the DC side is we have small DC boosters in order to achieve this lower input range for the unit itself. So the Gen 24 is available as a Primo, so single phase, and also the Simo range. So again, three-phase units that can be used as either a grid tie unit or as a full hybrid inverter. So again, you've got three-phase hybrid inverter, you've got 2 MPPT inputs, again, one single battery input on the DC side. And this is available in power classes 3 to 5 kilowatts. So for the smaller housings, which are exactly the same size as your normal single phase Gen 24. And then from 6 to 10, it's a larger housing that is holding the unit in place. And again, your input range, so it's very similar to the Primos. So you got 25 and 12.5 amp split between the MPPTs. And this is from 80 to 1000 volt DC for the Gen 24s. For the Taro series, so we have two different variations. So we have what we call the Fronius Taro Standard. So this is can be available for direct or pre-combined installations, depending on your needs for the client. And this is only available in power class of 50 kilowatts, but you've got 3 MPPT inputs on the unit. So the MPPTs are split. So you got 36 amps split between PV1 and PV2, and then PV3 would have then the combined 72 amps, for example. And this is an input voltage range of 400 to 930 volts. So depending on the power class that you're using, but again, we always recommend is to make sure that you are above this 400 volt input side, also for the usable range for the unit itself. Then we have the Fronius Taro Eco. So the Eco is referring to a single MPPT power class unit. So it takes its name from the old snap inverter Eco. It's exactly the same derivative and is also the same boards that are inside the unit effectively. So you've still got your single MPPT input. You've got your string fuses that are on the boards itself on the DC side. And again, it's available in power class 50 to 100 kilowatts. And then you've also got a voltage range that is very similar to the old Eco 27. So that's why we say it shares a lot of similarities between the two. So you've got 580 to 1000 on the input range. And again, your usable range would then be from 650 and above when using the Eco, the Taro Ecos. Next is your Fronius smart meter. So the TS is referring to touchscreen on the smart meter itself. So we always recommend to have a Fronius smart meter when you are doing a grid tie installation using Fronius inverters. So for single phase grids, you can use the 100A-1. So it's a pass-through meter for the client itself. For smaller commercial grids, we recommend using the 65A-3. So again, this is also a pass-through meter. For three-phase grids, small residential installations, and then for larger commercial side, we then recommend is the 5KA-3. So this is a CT meter, again for three-phase grids. We always recommend to use the Fronius CTs, but you can use third-party CTs as long as the quality of the CT is very high in that regard. And then Fronius has now introduced our new Fronius Smart Meter IP. So it's a very similar topology of the old 5KA-3. The only difference is on the communication side as well as the CTs. So for example, you would need to use a 200/5 CT. Here we then have to make sure we're using a 0.3 millivolt CT in that sense. So also it's important from Fronius is we are introducing our new small commercial inverter that's coming Q1 next year. And this is going to be known as the Fronius Verto unit. So this will be available in power class from 25, 27, 30, and 33.3 kilowatts. What's handy with this unit is we have stepped away from our old traditional of having either a single or two MPPT inputs on the unit. We've now split that to 4 MPP trackers in total on the unit. You've got 2 strings per MPPT. So that means you've got 8 string inputs that you can have on the units in total. And you've got 28 amps per MPPT and per string effectively coming into the unit itself. So it can withstand, the new module trend that we've seen where, you got a much higher current, for example. So this unit is designed to withstand up to 600 watt modules connected into the system. What's also handy is we've changed the MPPT voltage range. So instead of being, for example, 580 to 1000, we've now shifted it down to 150 volts, all the way up to 1000 volts, both on the input and usable range. So the usable range is from 150 to 870 volts, for example. So you got a much wider voltage range to use the Verto instead of the Echo, for example. So that's something new and exciting coming from Fronius. So next we'll just be covering is the professional installation of Fronius inverters. So this will be a broad spectrum of what to do when you are installing a Fronius inverter on site. So always what we do is we recommend our tech support area for installers. So always go on the website and just download quickly if you need a installation manual or quick start guide for the unit itself, as well as any data sheets. Software and updates can also be found here, as well as any additional trainings and webinars for Fronius itself. And also lastly is any certificates that are needed. So if the client is requiring an IEC certificate or NRS, it can be available on the website itself to be downloaded. And next, what we recommend is the Fronius e-manuals page. So this page is very handy for clients that are doing a smart meter into the system or doing a battery connection. So this will always give you a brief schematic of how exactly it needs to be wired up, for example. So if you're doing a smart meter, it'll tell you how to do the CTs to the meter as well as on the COM side. If you need to do a 120 ohm jumper, for example, it'll all be explained on the Fronius e-manual side. So again, it's an online manuals for all Fronius products. So it will show you exactly what is required when doing the installations. So when you are doing the installation on site, so the snap inverters and Gen24 can be installed indoors, so in a shaded environment. We do not recommend that the units are installed in direct sunlight. So this is just due to the heat sinks. So the Fronius, the snap inverters have the heat sink on the back of the unit, but it is still heavily affected by heat soaks. As well as on the Gen24, the heatsink is directly on the front of the unit. So again, the unit can be installed outdoors. It's IP66 rated, and it can be installed at altitudes up to 4,000 meters. But we need to keep in mind is our UDC max. So instead of being 1,000 volts, for example, it would shift down to 835 volts if we are installing at 4,000 meters above sea level. Again, no direct sunlight, no environments to animals or living conditions. So again, it's just due to the unit having exposed connections. So you will have cables coming out of the unit. Lastly is the in livable space. So this is due to the all units having active cooling. So they do get noisy with the fans that are running. So we do not recommend installing it in livable spaces. Whereas the Taro, for example, this unit is designed to withstand the elements. So it is designed to sit direct in the sunlight and have no effect on the heat soak from the unit itself. We get away with this with twin wall cooling that we have on the unit itself. So again, we do recommend to try and install it in a shaded environment, but if not, you can install it in direct sunlight. Next, for the inverter orientations. So again, vertical mounting on a vertical wall or pillar. Horizontal mounting is also achievable in the units, as well as mounting on inclined surfaces is also possible. So it's just to keep in mind of the wall bracket. So the physical bracket that holds the unit on place on the wall, that needs to be kept in consideration because it physically slides in to that wall bracket itself. Your safety clearances, so your distance between the inverters. So always with the SAP inverters, we recommend 100 millimeters between the units. So it's 10 centimeters from side to side on the big devices and 20 centimeters above the units, as well as 15 centimeters above for the smaller units. So this is just to aid with installing the units as well as to prevent heat soak, because what happens is the fans draw cold air from the sides and pushes it out through the top of the heatsink. So if there's a roof that is too low, for example, we would then be recycling that hot air through the unit and through the heatsink, and we'll eventually get a error code for excessive temperature on the unit itself. So again, for your wall bracket and wall mounting, so again, this is referring to our snap-in mounting principle or concept that we have. So the correct selection of your fixing materials. So again, either use 6 to 8 millimeter pre-drilled roll bolts or fissure plugs to hold the units in place. And then uneven surfaces are compensated to the greater extent. So just make sure that you avoid any deformations. So both on the Gen24 and snap inverters plates itself, simply because if we have a deformation on the snap inverter side, we would then be at risk of not being able to mount correctly, either on the DC side or on the AC connection point when the unit snaps back into place. So how would you know if it is correctly done? So you'll see is there's two simple eye hoops on the unit itself, and there's a visual check to make sure that it is clicked into place on the Gen24s. Whereas the snap inverters, we have to simply fix two screws that are Torx 25 in size. We need to at least tighten them to 2 Newton meters in order to make sure that the unit is correctly fastened in place. So again, the snap inverters wall bracket is a simple mounting and also a connection point for the unit itself, whereas on the Gen24, it simply is just a wall mounting bracket for the unit. It's for the unit. So you do get your integrated safety devices. So again, the maximum safety with Fronius. So the units will do an isolation measurement before DC is on. So it always uses a reference for the last DC measurement that it had the previous day, and it uses that as a reference for when the DC is then switching on. So typically what you'll see is if you've got a low PV voltage, you'll typically see like 306 or 307. It could be triggered by an isolation measurement that's still taking place or is not completed yet. Your RCMU, so monitoring of the feeding process for any residual currents that are present, as well as you've got grid fault detection, so your anti-islanding detection to detect a power failure and then switch off the inverter immediately. We also have reverse polarity protection. So we've got diodes in the semiconductor of the modules, obviously to allow for the short circuit. Your over voltage protection. So again, this is an optional retrofit kit that's available. And then lastly is the power reduction. So this allows for us protection against overloads and as well as high temperatures. So if the unit detects a certain threshold on the temperature side, it will go into a safety mode where it will allow the unit to produce 50% power. And if that temperature exceeds 85 degrees, then the unit will physically go into an idle state and switch off completely. So the wiring of the Fronius Gen 24. So you have to use a Torx 20 screwdriver is all that's required when doing the installation and commissioning process for the Gen 24. So what we'll need to do is use our Torx 20 screwdriver. We'll then remove the inverter cover. So it's two simple screws here on the bottom of the unit. You turn them 180 degrees to the left to loosen. We make sure the DC isolator is off. Then once we've removed the inverter cover, we then need to remove the DACOM cover. So it's 5 screws that are also held in by 180 degree quick locking screws. So you'll just simply remove them and then you'll remove the DACOM cover itself. Again, we recommend no cordless screwdrivers are allowed when doing the Gen 24, simply because we're using the 180 degree quick locking screw. Again, for the cable connection points, so this is as you have removed the DACOM cover, this is then the connection points for the unit itself. So on our left-hand side, we've got our DC connection points. So again, we've both got the module and our battery connection points both present on the same connector. So both for the positive and our negative side. In the middle is what we call the pilot device, so the pilot card. So this is the communication brain of Gen 24 and Tauro units itself. And then on the right hand side, we've got our AC connection points. So we've got our AC clamp for our normal grid connection. And then lastly, we have our PV point connection, which is here on the right hand side also. So again, the PV point is if the client wants to make use of power generation through the unit itself. If there is a power failure and they don't have a battery in this configuration, they can still use the PV point to extract that power from the modules through the unit to a dedicated output that they have located in the house. And again, we can do 2.5 to 10 mil squared cable size, as well as on the DC and AC side, but we are limited to only using copper cable. So we can't use aluminium cable for any of the Gen 24s. So also what's handy is we have what we call the grounding terminal block. So this is positioned below your AC clamps. So it's your grounding for further components if need be, so ground spikes, upright module mountings. You've got 2 fixing screws, so it's Torx 20. So you've got 4 holes that will accommodate for 2.5 to 10 mil squared cable coming in, and 2 that can accommodate 2.5 to 16 mil squared earthing cable that's then required additionally for the unit. So on the AC and DC cable glands, so we have a proper laying of your AC and DC cables. So on the AC side, we've got a strain relief M32, but you can mount the grounding with the gland itself. On the DC side, we've got a push through DC feed throughs that are manually pushed through. So very similar to the old snap inverters where you had a plastic stopper with a rubber push through for the screws itself. And then what we'll then use is the strain relief. Lastly, once we've done all our connections coming in on the DC side, we then fasten the strain relief to prevent anyone from being able to pull the cables physically out of the unit at the bottom here. Next, and importantly, is the cable gland for your data communications. So typically what we've noticed is clients will remove entirely all these red plastic stoppers from the gland and then simply throw it away. This will affect the IP rating of the unit itself. So what we recommend is to always remove the plugs that you are needing to remove. So if we have two cables coming in, we can remove simply two of the plastic stoppers, have our cables coming through. We reinstall this rubber with the plastic stoppers and then refasten the gland back into place. So next is the wiring of the Fronius snap inverter. So it follows the same basic concept as the Gen 24, apart from us not having Wagyu disconnect quick clamps for the DC and AC side, but we have physical termination points that we need to fasten into the unit. So what you'll notice again on the left-hand side is where your DC connection points is located, and on the far right-hand side is your AC clamps. So what happens is the MPPTs are split. So your 1 to 3 is MPPT 1, for example, and from 2 to 6, from 3 to 6, sorry, is your MPPT 2 range. Whereas on the negative side, they are both sharing a common bus bar on the negative side. So it's not that drastic for the negative side to be kept in from 1 to 1, for example. But if you can, please maintain, connection point 1 to 1, 2 to 2, for example, and so forth. Again, we'll have to use our strain relief on the DC side. So once we input our cables into the unit, we need to make sure that the strain relief is fastened over the cables to prevent anybody from pulling the cables directly out of the unit. So again, the connection of the inverter to the wall bracket, so again, it's referring to with the snap inverter range, we need to make sure that we have two personnel helping to mount the unit in place because it can weigh up substantial amount. So this Simo 20, for example, can weigh up to 45 kilograms, and it is quite awkward to carry. So that is why we always recommend having two personnel just to make sure that the inverter is correctly placed. Again, we emphasize it heavily is to make sure that the two screws on the far left and the far right hand side are fastened tightly. What we've noticed is some clients will avoid tightening correctly and they just leave it. And what happens is you'll develop arcs between either on the AC side or DC side. And this will greatly affect the unit and also on the RMA side. So we still recommend is making sure that it is installed correctly on site. So once we've done our AC and DC connection points to the unit and we've reinstalled the inverter, we fasten the two screws that hold the unit to the wall bracket. We then need to close the DACOM cover. So on the bigger units and smaller DACOM, snap inverter series, you will have a DACOM cover regardless of the size of the unit. The only main two differences is that the larger units will have 4 screws that need to be fixed into the inverter, and the smaller units will have simply 2 screws for closing up the DACOM cover itself. Again, we recommend no use of cordless screwdrivers or drills to fasten the screws, as it does bend some of the actual mounting fixture points inside the unit itself. So for the installation of a Fronius Taro, so what would be needed? So simply you would need a Torx 20 and Torx 25 screwdriver. Again, cordless screwdrivers are allowed, but only with specific torque settings, because there are quite a few screws on the unit itself to then remove and refasten. You'll need your quick start guide. So again, this is packaged with each individual product that you're purchasing. It is available, but you can also download it on our website itself at www.fronius.com. And lastly, what you'll need is our Fronius Solar Start app. You don't have to use the Fronius Solar Start app. You can do it on a laptop or a normal tablet or anything like that without having the app is possible, but we still recommend is having the Solar Start app on your device when doing the commissioning of either the Taro or the Gen 24 series inverters. So how the Taro can be transported. So again, it is quite a heavy device. So it weighs from anything 74 to 103 kilograms, depending on the power stack type that you're ordering. So the 50 kilowatt variant will weigh 74 kilograms, for example, and the 100 kilowatt is 103 kilograms respectively. So again, trains and ropes are allowed to be mounted on the holding eyes that are on the top of the unit itself. Again, make sure that you are using both holding eyes when you are transporting the unit, as it can swing quite drastically. So with the device, you will get your lightweight wall mount available in the box. So this will allow you to mount to the wall directly. So you will have to keep in mind is the distance between the units, as it is 50 centimeters between each unit, as well as the safety clearance from the top of the unit, as well as from a wall edge. So this is due to if you remove the covers and you need to remove a power stack, we need that 50 centimeters in order to remove the power stacks correctly out of the unit itself. Again, the unit does have active cooling technology. And again, we recommend 3 to 4 personnel to lift the unit correctly into place on the wall bracket itself. So again, I mentioned about the different variations of the Fronius Taros. So again, you have your pre-combined variant for your central system designs, as well as the direct variant for your decentralized system designs. So it all depends on the limitations for the site and also your cable losses that you have calculated on site. So if we can get away with more loss on the DC side compared to the AC links that we need to pull, we can then obviously use the pre-combined series. So which means we can get away with shorter AC runs, which obviously leads to less cable loss. Whereas depending on the design that we have, and this is typically what we recommend for the direct variant that you want to use. So what are the differences on the AC side? So again, on your central system design, you'll see on the pre-combined variant is you'll have 3 glands that can accommodate up to 95 mil squared cable coming through. You've got integrated V clamps and V terminals mounted on the DC side for the fixing of the cable, and we can have cable up to 240 mil squared, depending on what variation we are using. Whereas on the decentralized system design, so again, this is the direct variant, we'll have integrated MC4 connector points at the bottom, and we have string fuses that are also integrated on the inboard DC boards that are located inside of the unit itself. So again, we have different amps that we can have for the fuser side. So we can have 15 or 20 amp fuses on the board itself to then accommodate for if we're using larger modules. So we can change these fuses itself. Again, your AC cable connection points of up to 240 mil squared coming into the unit on the AC side. So if we are wiring up the DC wiring of the Taro Direct variant, so what we'll have is on the decentralized topology. So this is the Fronius Direct variant. So when you are ordering your Fronius Taro, for example, you'll see it'll either state 100D or P. This is what it's referring to, is either being the direct or pre-combined variant. So on the direct connections of your PV strings coming in, so on the 50 kilowatt devices, we got 14 strings in total. So it'll be split by 7 and 7. And then on the 100 kilowatt variant, we've got 22 strings in total on the unit. So it'll typically split by 7, 7, and 8, for example. And again, no usage of your DC combiner boxes. So like I mentioned, you have got your integrated string fuses on the unit. So you can have both 15 or 20 amp string fuses are standardized. And then your right choice for string fuses. So when you are ordering the unit, you can choose what variation of fuses you want in the unit itself. So you can choose between the 15 and 20, for example. and you can easily exchange of the fuses is also possible if there is a failure with one of the fuses. Next, and importantly for the Fronius Taros, is what we call the splitting of the PV strings. So your PV strings need to be evenly divided on your PV inputs. So both PV1, PV2, and PV3. So you need to make sure that we are maintaining, if it's 12 strings in total on the unit, so that we have 4 on PV1, 4 on PV2, and lastly 4 on PV3. So we need to make sure that we can evenly divide the strings as best as possible for itself. So what we do is we always recommend is using the Solar Creator tool, or Fronius Solar Creator tool, to input the data in that you are using. So it'll ask for the modules that you're using, as well as what version of Taro or what inverters you're going to be using. And then from there, it'll then correctly tell you how to string up the unit. So it'll tell you, okay, you can get away with splitting 5 strings on PV1, 4 strings on PV2, and doing 4 strings on PV3, for example. But we always say just double check the data that the Solar Creator tool is outputting to what you have on site. So on the DC wiring on the Taro pre-combine, so again, this is the P variant of the unit. So again, we'll have either 6 or 4 usable glands for the unit itself. So this will all be dependent on what variant we're going to be using. So on the Eco variant, we've got one single MPPT. We've got the 4 glands that we can use. So we can have either, 2 strings coming in, both positive and negative for PV1 and PV2. And this will be both for the Eco 50, 99, and 100 kilowatt variant, respectively. You'll have 6 glands available for you with the 3 MPPTs with the Taro standard pre-combined. So again, this is the unit that's only available in 50 kilowatt power class that we then can use for the systems. Like I mentioned, we have got dedicated V-clamps inside of the connection point for the DC side. So again, no usage of cable lugs is necessary, and also allows for fast installation with the direct connection coming in with mounting to the V-clamps. So lastly is the permitted DC cable cross sections that are allowed. So if you are using the Fronius Taro standard 50 kilowatt variant, if we are doing a direct connection coming in, we can use 2.5 to 10 mil squared, but please always see the data sheet to confirm what cable sizes you can use depending on the variant that you're using. So either being a Taro 50 standard or the Eco standard, for example, just double check what exactly is being referred to on the data sheet itself. Whereas on the pre-combined side, we can use 25 up to 95 mil squared cable coming through. And then lastly, what Fronius also offers additionally is our temperature resistant protective hoses. So if the cable cannot withstand up to 90 degrees centigrade, we always recommend is to use the Fronius protective hoses over the AC side or DC side, just to make sure that the cable is protected in case of that higher temperature. What's also very handy on the Fronius Taros is our integrated DC and AC overvoltage protection. So again, no additional boxes required. It's all installed internally on the DIN rail that's located inside the unit. So it's a high quality SPD, so it's exchangeable, and the feedback contact on the data communication unit. So the unit will physically communicate with the pilot device. So if either the DC or AC side has failed, we can simply see with the data that's output to SolarWeb, we'd be able to tell what exactly has failed before going out to site. So on the AC wiring of the Fronius Taros, so there is different options that are available. So this is briefly on the single core. So you've got 5 cable inlets on an M40 single conductor cable. So different cable diameters is possible from 10 mil to 28 millimeters squared coming in. We can use both copper or aluminium cable, but also just to keep in mind is the torque ratings when either using aluminium or copper cable is just to keep that in mind. We can also do multi-core. So again, this allows for one cable inlet, so conductor bundle. So big cable glands to allow for up to 61.4 millimeters in diameter, and also small cable glands of up to 25 millimeters squared coming in. So again, we always say is to mind the torques. So all depending on which cable you're using, both being aluminium or copper, is just to keep in mind on the torque ratings when you are fixing the AC cable. Lastly, on the AC side, is a feature that's very handy for the towers itself is what we call AC daisy chaining. So you'll have 10 cable inlets, so M32 single conductor cable. So it's an AC input and output on the AC side. So the first tower and chain will then be a single core is sufficient for it, whereas the last one will have the AC daisy chaining option, for example. So this allows us to get away with reduction in cable costs on the AC side because we can simply run for every 4 units that are using on the 50 kilowatt variant. So we got a 200 kilowatt limitation for the last inverter to push that cable back to our distribution board. So we can either have 4 by 50 kilowatt units in the series or having 2 by 100 Fronius Taros. So that way we get away with using less AC cable. It's again bringing down our BOS in terms of the system itself. So you will have V clamps in the AC connection area. So again, you can use solid round conductor, stranded round conductor, solid sector conductor cable, as well as stranded sector conductor cables, as well as fine core cables, only conjunction with if you're using bootlace ferrules, for example, and using an M10 cable lug on the threaded bolts. So again, the delivery conditions, so it's anything from 25 to 150 mil squared, and then changing of the V clamping area to then accommodate for 185 to 300 millimeters square cable coming in is also possible. So what we'll simply do is remove the V clamp out, just swap the orientation, and then refasten it back in to allow for us to mount either a smaller cable or a much larger cable in that sense. You have also got an option for our integrated AC disconnector. So as you know, Fronius comes with DC disconnectors already built in on the unit itself. So this will either be located on the bottom or the front of the unit, but the Taro allows for us to do an integration of an AC disconnector. So again, this is optionally integrated. So from factory, it needs to be ordered with this AC disconnector installed, and it's only available for units that have single core or multi-core cable configuration. So if you're using, let's say, our tower configurator tool, if you are selecting the single core and multi-core, you will have the option for the AC disconnector. But if we choose the AC daisy chaining option, we cannot then select the AC disconnector is then not available. So again, on the cable sizes, so again, with the Taro standard 50, so the 50 kilowatt variant. So this is both for the standard and optional AC disconnector as well as daisy chain options. So you can have AC cable coming in of either 35 to 240 mil squared. But if we are using the larger variant units, so like for example the Taro Echo 99 and Echo 100, we are then limited on the AC side from 70 mil all the way up to 240 mil squared coming in on the unit. Again, we also state is the temperature resistance of the AC cables must be at least up to 90 degrees centigrade. If the cables cannot withstand that temperature range, we still say is to order the Fronius protective hoses, which is available with the following article number, to then allow for us to make sure that the cable can withstand the internal temperature range that the unit can go up to. So if we are needing any additional earthing that's required on the unit, we can simply drill a mounting hole for a gland on the right-hand side of the unit, but just keep in mind of the distances that we have in place. So it must be at least 2 centimeters from the edge of the unit and not greater than 10 centimeters out from that 2 centimeter range. So this is just due to the welding that's been located on the unit is within this 2 centimeter range. So that's why we stipulate that it must be above the 2 centimeter edge of the unit itself when drilling your own glands for additional earthing. So again, for the completion of the installation, so we have properly carried out our AC and DC cabling. So again, we will need to make sure that additionally or optionally is our AC disconnector is on the on position. We'll screw on the front cover with 7 Torx 25 screws with up to 3.5 Newton meters. We will then turn on our DC disconnector switch, and then it will then allow us to then open up the Wi-Fi access point on the unit itself. So next we'll cover is the data communication of the Fronius Gen 24 and Taro. So this is referring to the pilot device, so how exactly it would communicate and the commissioning process of it. So again, the two units share the same communicative brain, being the pilot device itself. So we can have the connection either being WLAN or LAN connection coming in directly from the router itself to the pilot device. And this will then allow us to then output the data through to SolarWeb for full visualization. So again, we still recommend it is available on your browser itself, as well as a downloadable app through either the iOS or Android devices. So you can download the SolarWeb app itself. So again, with the communication coming through to the pilot device, this will then allow us to do the commissioning of the unit itself. So again, this is making use of the SolarStart app. So there's 3 simple steps when using the SolarStart app. So we'll have network, product, and then lastly SolarWeb to then carry out the full commissioning of either the Gen 24 or Taro device that we are using. So again, the data communication unit or pilot device, so it's got LED status displays. So we've got a way of using an LCD screen on the front of the unit to display any error messages or power output from the unit. It's a data logger, web server, and Wi-Fi card. So again, you can do full visualization through our SolarWeb portal, as well as using the SolarWeb apps. And lastly, using Solar TV, which is available on both the data managers and the pilot devices. So with the pilot, we have multiple open interfaces. So we've got 2 Ethernet ports. So we can have a LAN connection coming in. So we can have Modbus, TCP, Sunspec, or Solar API JSON protocols that are used with regards to the interface. We also have an additionally 2 Modbus RTU, so RS485 interfaces built in on the unit. And then lastly is the WSD function, so wired shutdown. So it's if there is an e-stop that you want to trigger in case of an emergency, we can have it where the e-stop will trigger the WSD function on the unit itself, and it will cause the unit to then go into an idle state. Lastly is our digital inputs and outputs, or IOs. So if we want to do intelligent load management, we can use the inputs and outputs to control the unit separately or to try and trigger different relays to open and close with simple PV surplus that's available. So again, on the Modbus interfaces, you've got your Modbus RTU or RS485, which is a push-in connection plug, which is those 2 orange connector plugs that are available. So the one is for your RS485. So you've got M0. M0 is one of the protocols, and you got M1 as the other protocol for your Modbus side. So what you'll see is there's a simple switch located on the top of the pilot device itself. So this is to allow us to turn on our terminator resistor or 120 ohm terminator resistor for the unit itself. So this is handy when we are doing a smart meter to the system. We will need to make sure that we have the terminator resistor either on or off, depending on what different smart meter we are using. So some smart meters required, some don't require you to having that resistor turned on or off. So mentioning the Fronius smart meter, so when you are doing the wiring of the meter itself coming in, so we need to make sure that we're using M1 negative and M1 positive, as well as our grounding for the unit itself, and also the shielding, which is then back to the inverter itself. So what you'll notice is we'll have a simple jumper between 7 and 8. So this is referring to that terminator resistor that needs to be enabled, which will then be triggered by those terminator resistor dip switch switches itself. Lastly is your WSD interface, so your wide shutdown interface that's available for as a safety mechanism. So again, it's bridged from factory, and this allows us to use up to 10 devices with one master being responsible for your e-stop that's been triggered. And we can have distance between two devices being 100 meters and below. So it allows us to do up to 1 kilometer in total between the master and our last slave if we are using this WSD interface. So again, what can the WSD be used for? So again, it's used as a fireman switch. So it can be for a safety element, so application in practice. So this has become a normative order in the USA, and as well as country and region specific legislations require that you have an e-stop that can trigger the inverters to shut down, whereas we will typically trigger, for example, the AC isolators to then trigger or close to then cause the inverters to go into an idle state. So it's just different ways of different legislations regarding the safety devices. So again, if we are making use of it, again, it is bridged from factory. So if you're not using it, you don't have to stress about doing any additional wiring or switching on or off of the WSD function. But it's only if we are using multiple inverters, we then need to make sure that we're using a Cat5 twisted pair for both in and out to then allow us to then communicate correctly with the WSD. So what we'll also need to do is the master will be on 1 and the slaves will be on 0 respectively in the system that we are using the WSD. Next is just an overview of your integrated interfaces, so what we refer to as our digital IOs. So you got 4 digital inputs and outputs, as well as 6 digital inputs on the unit itself. So you got 12-volt DC 6-watt signals that can communicate with the unit itself. So this is where we then utilize our intelligent load mapping or load management. So this is if we have, for example, a pool pump, an aircon, or charging stations for electric vehicles, as well as heat pumps. We can then have it where it will trigger different relays to open and close. If we want the pool pump to run for an hour, for example, we can trigger it where we say if there's a PV surplus of 2 kilowatts available, have it where the relay can open for 45 to an hour every day between certain time periods. We can then do that through this intelligent load management with the units. Lastly is just your cable connection for the data communication side. So in the LAN connections, we have a maximum of 100 meters from the device to the router or switch that you're using in the system, as well as being Cat5 STP or UTP cable and above. So you always recommend using Cat5 or Cat6. Doesn't need to be anything fancy like Cat7, for example. So just normal Cat5 is more than sufficient on the LAN connection side. For Modbus, your max cable cross section is 1.5 mil squared. So this is why we typically recommend is using twisted pairs for the Modbus RTU communication side, and you've got a max cable length of 300 meters from the device to the inverter itself. So if you've got a smart meter in the field, 300 meters from the inverter is the maximum length we can have the smart meter located. Again, using Cat5 SDP cable, again using twisted pairs. For the IOs, so your inputs and outputs, again 1.5 mil squared, 30 meter max cable length, and then also having single layered apostle is also. Whereas on the WSD, so your wired shutdown, again you got 1.5 mil squared, 100 meters maximum between the units, so between one device and the other, and again making use of your Cat5 UTP cable for the system. So once you have done the AC DC connection coming into the unit, we can then do the commissioning of it. So this will allow us to do the Wi-Fi access point. So how do you open the Wi-Fi access point? So again, once you've done the commissioning, the installation itself, we will then hold our finger over the light sensory button in the middle of the unit, and this will then allow us to then open the Wi-Fi access point. Once the right hand side LED is in flashing blue, that means the access point is open, and we can now connect to it either via a laptop or phone to then allow us to then start the commissioning process. So again, how does the inverter communicate? So like I mentioned, with the pilot devices, we've stepped away from using an LCD screen to then notify us of any errors. So whereas we're using LED status for that, so if the unit is green and blue, solid blue, that means the unit is online and operational, and it is online and communicating 100% to the cloud itself. If it is yellow, it's in a standby mode. Yellow flashing is then a warning, and red is a simple error that's located on the unit. So again, green and blue means the unit's 100% and communicating, so we don't have to stress on site. The data communication of the Fronius snap inverters. So again, this is for the initial commissioning and installation. So this is where we'll have a integrated interfaces. So just a brief overview. So you got your solar net ring. So this is port 1 and 2. So these are your two RJ45 connector points for the DACCOM side. 3 is our USB interface. So then this allows us to do USB updates, as well as us to do data logging with a USB on site if need be. 4 is our relay outputs. So again, if we want to trigger relays directly from the unit itself, we can utilize the relay output. 5 is the antenna. So just make sure that the antenna is in place when doing the opening the Wi-Fi access point, because if not, the signal strength will be very low and you will constantly lose connection if the antenna is not in place. 6 is your one Modbus RTU connection block, so RS485, as well as for your digital IOs for the unit also respectively. 7 is your Ethernet interface. So again, if we're using Modbus TCP or solar APIs or physical internet connection coming in, will be 0.7. And then lastly, importantly, is 0.8, which is our status LEDs. So again, very similar to how the pilot device relies on an LED status of being green and blue to notify us that the unit is 100% operational and communicating correctly. The same applies to the data manager card, where we'll have, if all 4 green LEDs are present, that means the unit is online. It has a complete solar net ring, and it also has a valid internet connection for the unit itself. So again, with your Fronius Data Manager card, you can do the monitoring up to 100 inverters in the system, but just keep in mind, if you have got multiple inverters and your ring length exceeds 1 kilometer, we need to do a physical connection to then close the loop entirely. So what you'll typically see is you'll have end-of-line connector points located on the master and the last slave. So what we typically say is if the distance is greater than 1 kilometer, make sure that you're running a physical cable to close the loop between the master and last slave. Again, it is a visualization card that's available to allow us to do through SolarWeb Portal, as well as using the SolarWeb apps, and lastly, the Solar TV. Again, you have multiple open interfaces. So again, using your Ethernet or LAN port for Modbus TCP Sunspec, or your Solar API JSON protocols. And again, on the orange plug, so this is for your communication of RTU or RS-485. So you'll have D plus, D negative for your smart meters, for example, and V plus and ground, and your IO ports respectively for your RS-485 connection block. So again, for your Fronius Solar Net, so the Solar Net is referring to how you communicate from inverter to inverter when only using a snap inverter range. So this allows us to do echo to a SIMO 20, for example. So it's 3-phase to 3-phase. We can then do communication with one master being the device that has the data manager card. And then what we'll do is we can then have a simple RTU UTP cable connection point between the two units. So we'll go from out to in, and then from out to in, for example, and we'll then follow the train like such for the communication side. So again, making sure that we have got our end of line termination plugs on the outside for the unit itself. So both on the last slave and the master will both have one of the RS-485, RJ45 end of line connection blocks. So there's important settings and parameters when you are using SolarNet. So make sure that the termination plugs are correctly installed. The addressing of the inverters is very important. So we need to make sure that we start the master at 01 and the first slave is then 02, for example, and then following on as such. So again, one data manager can connect up to 100 inverters and then mind the master slave position if there are multiple data managers present in the system. So on the data manager card itself, there is a simple dip switch, which will allow you to turn that card into a master or slave. So if we have multiple units that we've ordered on site that have got a data manager, we need to make sure that we switch all the slave units back into slave mode on the data manager card itself. So for opening up the Wi-Fi access point, so how do we do this? So once we have booted up the unit, so we've both entered the correct language and all the protocols for the unit, so such as your country code, we can then open the Wi-Fi access point, which is simply going by setup, Wi-Fi access point, and then activating it lastly. So there's important notes to make note of when the Wi-Fi access point is not available. So we always say to wait briefly. So what happens is the unit will do a DACOM check to make sure that the DACOM is 100% before allowing you to open up the Wi-Fi access point. So if it is not available, we always say check the SolarNet ring. So this is in turn making sure your termination plugs are in point. Check the protocol is set to SolarNet and not interface on the unit itself, and make sure that the IP switch on the bottom of the card, on the data manager card, is set to B and not A. So with the initial commissioning of your snap inverters, so this is these 5 or 4 simple steps that will pop up when you are using a snap inverter, is what we like to call the installation wizard. So when you are first booting up the unit, you'll have an option to select the language that you are using, the country code setup, you'll set your date and time. And then lastly, if the unit has got 2 MPPTs, we will then be able to set if MPPT 2 is on or off. And this can be re-entered via the AC reset code that is available to you on request from Fronius. So once we have connected to our Wi-Fi access point, we will then find this under our Wi-Fi connections. So it'll typically be a Fronius followed by a serial number. So this is for your Gen 24 or Taro devices will have this, where it'll be Fronius followed by the physical serial number, whereas the data manager cards will simply display a 240 number, which is known as the data logger ID. So with the Gen 24 and Taros, they'll all have a unique password. So we have stepped away from using the 1, 2, 3, 4, 5, 6, 7, 8 for all the pilot device cards. And this will be located on the side of the device with the sticker itself that stipulates the power class. You'll then find the unique password for the Wi-Fi connection point for the system. So once we've connected to the device itself, we will then open up our browser, and in the browser we will enter 192.168.250.181 in the address bar. And this will then open the installation wizard for the Taro or Gen 24. So again, it'll be 3 simple steps. So it'll be network, followed by product, and then lastly SolarWeb to then carry out the commissioning for it. So again, just a few on the wiring of the smart meters. So again, making sure that your 120 ohm terminated resistor bridge on the smart meter between ports 7 and 9 is in place depending on the meter that you are using. So if you're using the TS65A-3, so it'll be port 8, 9, and 10 that you're using. Whereas if you're using the older smart meter, which is the 63A-3, it'll be A, B, and C that you're wiring from directly from the meter itself. The Fronius CTs, so if you're using a Fronius smart meter, we always recommend to try and use the Fronius CTs for the smart meter. But if not, we always say is to recommend to use a very high quality CT just to make sure that the measurement values are correct. So the current ratio must be configured in the smart meter settings itself when you are using a CT meter. And Fronius recommends a max CT size of 400/5 when you are using the 5Ka or 50Ka smart meter variant. But you can use larger CTs, but there is certain parameters and documentation that explains how exactly to use them. With the Fronius smart meter IP, so again, this is referring to the new smart meter that's available. So this can only be used with a pilot device. So again, this will be either with a Gen 24 or Taro, or going into next year, the Verto devices will be able to accommodate for the smart meter IP. So the main difference between the units between the 5Ka and the smart meter IP is the communication side. So this allows us to do either a RTU connection point to the inverter itself or doing a TCP connection. So if we have got a site where we have a distance greater than that 300 meters, for example, we can then simply put in a LAN connection directly into the unit, and this will then communicate via Modbus TCP directly to the master inverter in the configuration itself. So again, on the communication path, a static IP is recommended if you are using the smart meter IP. Again, using Cat5 or higher, and then also see having a shielded twisted pair cables with the unit. We can also do a Wi-Fi connection directly into the smart meter itself, but you will need to use a phone to then correctly configure the smart meter itself. So next is just on energy profiling. So this is if a client has multiple meters that they want to use for different features and functions. So if we have a specific load that we want to measure, for example, a geyser or a separate inverter in the system, we can have up to 4 meters in total. So you'll have one master meter and you'll have 3 separate consumption meters individually in the system itself. So this allows us to do separate monitoring on SolarWeb, and we can even give a name dedicated to that meter. So we can name it as DB1 or DB2, for example, and we can then see on SolarWeb how much power exactly is being consumed by that dedicated smart meter itself. So if we are using multiple smart meters, we then need to do it. We do addressing of the Fronius smart meters. So as default from standard, when you are receiving the unit, it'll have Modbus address 001, which means it is then set to as a master smart meter, which means it's typically located at your main grid or feeding connection point. And then any additional meters that we have in the system, we need to assign from Modbus address 2 upwards. So we'll have Modbus address 2, 3, and 4 available to us that then allow us to then communicate correctly to the inverter and then thus directly to SolarWeb for the data. So what we'll do is if we want to make use of multi-smart metering, we'll then need to change it. So what we'll do is we will then hold the adjust confirm button, and this will then allow us to then get into the meter. We will then hold or enter the code 2633. This will then allow us to change that Modbus address number. Once we are then happy, we then simply will close out once we've reached page 18 on the meter itself. So lastly, what I'd like to talk about is the dynamic feeding management with several inverters. So what we call SPC or system power control. So this is a new feature from Fronius for clients that are using both snap inverters as well as pilot devices in the system. So the general information that we typically had regarding multiple Gen 24 or Taro inverters. So it was commonly known that you would need a third-party controller for the unit or having one master inverter which offers that dynamic feeding limitation, and then having a additional meter, for example, in the system to try and get away with having 2 or more pilot devices in the system. So the feeding limitation now, so the example that we're using is 24 kilowatt peak PV. So you've got two Gen 24 10 kilowatt units in the system, and our feeding limitation is set to 5 kilowatts. So the limitation of the master inverter is only possible now, and the Gen 24 remains, the slave remains at the same level, which means that our feeding power of 10 kilowatts in total for the system. So again, if we are making use of the dynamic feeding limitation with multiple inverters, so what happens is you will then have a dedicated router in the system or an existing one, and we'll then need to assign one master in the system. So this will either be the Gen 24 or Taro or Verto being the master as it has got a pilot device. If we have got a Gen 24 in the system that has got a battery, it outranks the Taro or Verto in the system, for example. So just keep that in mind if you have got a client that has got a Gen 24 with a battery and they want to make use of additional units, the master will be the Gen with the battery itself. So with us having the one master assigned, again, either being the Gen 24 Verto or Taro, we will then make sure that we have one Fronius smart meter connected. So again, this can either be the TS, IP, or WR. So either using Modbus RTU or TCP comms directly to the router or via directly to the inverter. And this will allow us to control up to 19 slave inverters in the configuration. So again, we can have both Gen 24, Verto, Taro, and snap inverters as slaves in the unit, but the limitation comes in with having multiple snap inverters is that we can only have 4 slave or 4 light versions of the snap inverters to every single data manager or full version snap inverter that's located in the system. So again, we typically say is having a 5-device solar net ring that we want to make use of when using the SPC power control. So this communication is all done via Modbus TCP. So it's not a physical change that needs to occur to the units. It's a simple software update. So you'll need to make sure that you're on version 1.32 to make use of this feature with future devices and systems. So just a brief example of different solutions. So solution 1 is if the client has multiple Gen 24s. So again, the Gen 24 with the battery becomes the master, and that will then have its Fronius smart meter communication directly to it. And then the additional 3 Gen 24s become a slave configuration, all communicating via the router via Modbus TCP, all directly back to the master itself. If the client has a Gen 24 Plus with a battery and they have multiple snap inverters, so again, the master becomes the Gen 24 because it has a pilot device and also it has got the battery communication to it. Again, you'll need to make sure that we have the smart meter communicating directly, and we'll need to make sure that we have only 4 snap inverters with the data manager that are then communicating directly to the unit itself. So if we have got 12 snap inverters in the system and we've only got 1 data manager existing, we would then need to make sure that we have an additional 2 data managers to then, in order to complete the loop correctly, and then allow the communication back to the master with the battery itself. Solution 3 is if the client has got multiple Taro devices. So what we like to say is you can do up to 20 Taro devices connected into a simple system with a Fronius smart meter IP. So again, this allows for us to do a system size of up to 2 megawatts effectively with just one simple master and simple smart meter connected to the system itself. So again, it's very similar. So we'll have the master assigned where it'll have its smart meter IP communicating via Modbus TCP. And this master will then communicate via this TCP loop back to all the slaves in the configuration itself. Again, the reaction time is usually not sufficient for large scale systems. So if we are doing systems where it is 2 megawatts, for example, a third party controller may still be required regarding the reaction time if we have loads that fluctuate quite heavily, and as well as using external grid and system protection devices, such as using your WSD wiring for this configuration is recommended.
Byron,
Yes,
just on
Alton.
that question, is it because of the Fronius smart meter, or what causes that you need a third party device?
It's the Fronius smart meter itself.
Okay. So the settling down of the inverters is still fast enough. Like the
It
ramp down
is,
into, yeah.
but it's due to the communication directly from the smart meter. It's not quick
Oh,
enough. So
okay,
that's why
perfect.
we
I see.
recommend having that meteor control in place to make sure that we then obtain that correct reaction time.
Okay, perfect. Thanks for that.
So again, it's just a simple requirements when you are making use of the SPC or system power control is to have one master in the system. So it'll either be the Gen, Verter, or Taro. Again, with special settings. So if, for example, if the Gen has the battery, it becomes the master and overrides the Verter or Taro in the system. We need to make sure that we have one Fronius smart meter always connected in the system. And again, mentioning about the one battery storage connected is then the master itself. Again, we can have up to 19 slave inverters. So they can either be snap inverters, Tauro, Verto, Gen 24. and you'll simply do this with the activation of your Modbus TCP interface and Modbus control settings, both on the snap inverter and on the Gen 24 or Taro device that's in the system. Again, we need to have the network router located in the system that all inverters can connect to and communicate, because we're relying on Modbus TCP. And lastly is making sure that we have got version 1.32 installed onto our pilot device cards. So you'll see it will be a similar naming of 1.32. So it will be a software version ending in 32 for the data manager cards. So if we want to make use of this, we need to make sure that both the snap inverters and the pilot devices are on the latest firmware versions to then allow us to use the SBC. So there's a few technical exemptions. So what's still impossible with using SBC? So the passing on Modbus or ripple control signals from the grid operators. So again, making use of IO power reduction is still not possible, as well as the operation of several Gen 24 plus inverters with each one having one or more batteries is not possible. So you'll need to make sure that they are a separate, they are a separate entity entirely when using SBC with systems that have got one or more battery in the system. And then your emergency power operation with several Gen 24 plus inverters in the network. So again, making use of your PV point, for example, or making use of three-phase emergency backup power will then not be allowed with several Gen 24 plus inverters in the network. So for the installation and commissioning of this simple feature, we then need to make sure that we set the export limitation on the master inverter. So you can set this as a soft limit because we are using multiple inverters. So we'll need to set the total DC power for the system itself, and then also is then to add all slave inverters. So we'll then enter the IP addresses of those slave inverters. So under the network connection, we will then enter the IP address that we've assigned. So typically what we say is use dynamic, but you can use a static IP. And then from here, the unit will then try and detect the inverters that it can find on the network in the TCP network. So here it will find the additional network devices and then also notify you of what IP address it has found, for example. So this will allow you to then control and correctly see which units are communicating 100%. So if it shows inactive, it means that the slave inverter is not configured correctly. Disconnected means the inverter is configured, but there is no internet communication. So this means it could be a simple IP address that's conflicting with the units, and connected means that the slave inverter is ready to be controlled 100% via the master unit. We'll just need to make sure that we activate the Modbus TCP on our slave inverters. So again, if we have got the slave inverters that are using a pilot device, we then need to make sure that we activate them as slave, as Modbus TCP, and then set the IO power management priority to 1 on the pilot device cards that we are using. So again, here is the controlling priorities. So again, we'll make sure that it is IO power limit is on our top priority in this sense. And then optional extra for your feed-in limitation to 0 watts. So this is only if a fallback scenario is required. So what I'll typically recommend is using a negative value. So setting a minus 500 watts as our fallback scenario. So that way we are never always riding at that 0% and limit of pushing back into the grid directly. So you'll simply activate it as normal. So you'll just add the additional components to your SolarWare profile. So from here, we'll then add a pilot device to the system, and then we can then have full visualization through the system itself. So what's the summary for using the SBC? So what's most important? So again, we can have up to 20 inverters with the master being the Gen, Verter, or Taro. Maximum of 5 snap inverters per solenoid ring. Maximum of 1 Gen 24 plus inverter with a battery, as well as all slave and master inverters in the same network. Again, having one Fronius smart meter in the system is essential for using SBC. And then your external I/O signals are not forwarded from the master inverter onwards, for example. So that's for today's training on Fronius products. So my details are followed below. So for any technical sales advice that you are needing or require, you can then contact me below, as well as for technical requests, trainings, international sales department, as well as our after sales service department. You can contact them directly.
Okay. Thank you, Byron, for that. That was a very fruitful training, and I'm pretty sure most of us learned a lot here. And yeah, does anyone have any questions? If anybody has a question, they can just drop the questions on the meeting chat. But I think we can then call this the end of the training if we do not have any questions. I'll just give it 5 more minutes or less, and then just see if there's any questions, and then we can just take it from there. But
Okay,
Byron, thank
perfect.
you, Wahoo. Okay, I don't think we have any questions. We can then call it the end of the training. Thank you everyone for joining, and see you soon on the next training.
Thank you. Thanks for hosting.
Yes.